In this video, we are going to discuss about voltage regulators. So the function of the voltage regulator is to maintain a constant DC voltage at the output, irrespective of the voltage fluctuation at the input. This input we are obtaining from the filter output. That is, you can see basically we need to convert the AC signal into DC signal, right? So for to convert the AC to DC, the first stage is to connect a rectifier. So the output of the rectifiers is unregulated because that the unregulated voltage is due to the fluctuation in the temperature, and if the load voltage or load current changes, so these are the causes of the voltage fluctuation, or it also depends on the AC input voltage. So here, with the help of the voltage regulator, I can produces whatever the DC voltage I want to get. So in other words, this voltage regulator provides a regulated DC output voltage. These voltage regulator are also available in the integrated IC forms. So before going to that one, we will discuss about the types of voltage regulator. There are two types. One is fixed voltage regulator, another one is adjustable voltage regulator. As the name suggests, the fixed voltage regulator produces a fixed DC output voltage, which is either positive or negative. In other words, some fixed voltage regulators produces positive fixed DC voltage values, while other produces negative fixed DC voltage value. So I told you know the IC name. It starts with 78. For XX, if we substitute 0.5 means it will produces to 5 volt. Okay, 5 volt DC voltage. So the 78XX voltage regulator ICs produces positive feedback DC voltage value, whereas 79XX voltage regulator ICs produces negative fixed DC voltage value. The following points are to be noted while working with 78XX and 79XX voltage regulators. So this X's correspond to a 2-digit number, and it represents the amount or magnitude of voltage that the voltage regulator ICs produces. Both these regulators have 3 pins each, and the third pin is used for collecting output from them. The purpose of the first and the second pin of these two types of ICs is different. The first and the second pin of the voltage regulators are used for connecting the input and ground respectively, and it is similar for 79XX. The examples is 780X produces positive 5 volt DC output. 7905 voltage regulator IC produces minus 5 DC output voltage. So this is a figure which produces fixed positive voltage at the output by using a fixed positive voltage regulator with necessary connections. So the positive input, you have to connect the unregulated output voltage and the input voltage, and you will get the regulated DC output voltage at the positive output. So in the above figure, this shows us a voltage fixed positive voltage regulator. This input capacitor Ci is used to prevent the unwanted oscillation, and the output capacitor C0 act as a line filter in order to improve the transient response. There are 7 types of 79XX that's available. One is 7905, another one is 7906, 7908, 7912, 7915, 7918. That is, it produces minus 18 volt. Then 7924. So these ICs are provided with adequate heat sinking, and it can deliver output current more than 1 amps. These ICs don't require any external component. These are provided with internal thermal protections, overload, and short circuit protection. The 2 series, that is 7824, it is for producing positive 12 volt DC, right? Which are available in various versions like low power and high power version. The low power versions are available in plastic or metal packages like small signal transistor. The high power versions are packed in T03 type metal cans or in T0220 type molded plastic packages like power transistors, which are shown in this figure. So you can see the first you have 3 pins. So one is input and output, and other one is ground. Okay. So here you have uh, the maximum input voltage for the 7805 is 35 volt. So if I want to produce output of 5 volt, I have to use 7805, right? So if the maximum output voltage is 2.5, means here hence the minimum input voltage required is 5 plus 2.5, that is 7.5 volt. So the input voltage range of IC 7805 regulator is 7.5 volt to 35 volt in order to produce a fixed 5 volt regulated output. So what does dropout voltage? So it is a maximum voltage that must exist between input and output terminal, as mentioned earlier. So it is a difference between the input voltage and the output voltage V0. So for most of the regulators, it is 2 to 3 volt. Next, ripple rejection. So it indicates regulator's ability to reject ripple voltage present in the input. It is defined as a ratio of the RMS input ripple voltage to the RMS output ripple voltage. It is expressed in decibels. So these are the uh, number of performance parameters mentioned by the manufacturers of IC voltage regulators. So the next one is line regulation. So it is defined as the change in the input voltage for a given change in the input voltage. Line regulation. It is defined as the change in the output voltage for a given change in the input voltage. It is expressed as a percentage of output voltage or in millivolts. Next one is load regulation. There is a change in the output voltage over a given range of load current. That is from full load to no load. It is usually expressed in millivolts or as a percentage of output voltage. Next one, output resistance. It is the rate of change of the output voltage with respect to the output current. It should be as small as possible. Next one, maximum input voltage. So this is a maximum input voltage that can be applied to the regulator safely. Next one, maximum power dissipation. This is the maximum power which a regulator can dissipate without damage. The actual power dissipated is approximately equal to the voltage drop between the input and the output terminals multiplied by the current through the regulators. For many regulators, it is internally limited. Next one, present current, IQ. It is also called as standby current. This is the supply current drawn by the regulator without any load. It can be also defined as the current that must flow from ground terminal of the regulator to operate safely. Next one, rated output current, I naught. It is a maximum value of the output current above which current limiting occurs. Output noise voltage. It indicates the tendency of the output voltage to fluctuate above its prescribed DC value over a specified frequency ranges. Next one, maximum operating junction temperature. It is the maximum value of junction temperature above which the thermal shutdown occurs. Out of these parameters, maximum input voltage, maximum power dissipation, maximum operating junction temperature, etc. are called as absolute maximum rating of the IC regulators, while other ratings are called as electrical characteristics of IC regulators. So next, let us go for adjustable voltage regulator. So it produces DC voltage which can be adjusted to any other values of certain voltage range. Hence, the adjustable voltage regulator is also called as variable voltage regulator. The DC output voltage value of adjustable voltage regulator can either be positive or negative. Example for this one is LM317. So it can be used for producing a desired positive fixed DC voltage value of the available voltage range. It has 3 pins. The first pin, it is used for adjusting the output voltage. Second pin is used for collecting the output, and the third pin is used for collecting the input. The adjustable pin terminal is provided with a variable resistor which let the output to vary between a wide range. So here you can see the block diagram. You have the variable resistance R2. So if R2 changes, I can change the value of the VR, right? My output, positive output. So this figure shows an unregulated power supply, that is positive input, driving a LM317 voltage regulator, which is commonly used. This IC can supply a load current of 1.5 amps over an adjustable voltage range of 1.25 to 37 volt. So the applications of Thus, voltage regulators are it has it is to provide a constant DC voltage to various components in the complex electronic circuits. For example, 7805 it will produces constant 5 volts supply to the digital circuits. And if you want to operate the operational amplifiers, that is you can see it require positive 12 volt and negative 12 volt. So I require IC 7812 and 7912 for the proper operation. Now